Good day, engineers. So we are on the last part of our discussion on the shear strength of soil. This is Engineer Rodolfo, and again, this is for the course Foundation Engineering. Start natin yung discussion. So for our next type of test, meron tayong unconsolidated undrained test or the UU test. So from the name itself, the first stage will be unconsolidated, meaning hindi natin i-consolidate yung soil natin. So on our first stage, yung inlet pipe natin open and papapasukin pa rin natin yung hydraulic pressure sa kanya, which is sigma 3 or yung chamber confining pressure. Pero since unconsolidated yan, ang mangyayari is yung outlet pipe natin is nakasara. So the drainage is prevented. So, ibig sabihin, walang lumalabas na tubig dun sa soil natin. So, that means there is a change in the pore water pressure. Now, on the second stage, undrained siya. So, ibig sabihin, we will increase or we will add a load or additional load at the top. So, which is delta sigma. Pero, i-ensure natin that the outlet pipe is closed. Therefore, there is still a change in pore water pressure hanggang mag-fail siya. So, ibig sabihin, mag-fail yan ng basang-basa yung tubig. Since there is delta U or a change in pore water pressure. Now, if we will plot this on a more column failure diagram, we will get this diagram. So, we will first plot sigma 3, then yung additional load, kung saan siya mag-fail, which is delta sigma, then we could create the more circle itself. Now, as you can see, yung horizontal line niya, or yung column failure line niya is nasa taas. There's no such thing as an angle of internal friction for this one. Kasi, punong-puno na masyado ng tubig yung soil natin. So, there's no such thing as friction for our soil. And, ang meron na lang doon is cohesion or purely cohesive kasi malagkit na yung soil natin due to the change in pore water pressure. Now, since ito ngayon yung more envelope or yung column failure line, ibig sabihin, this one is also our cohesion or the radius of the circle, which is delta sigma over 2. And as you can see from this one or from this diagram, ang angle is 90 degrees. Therefore, the angle of the failure plane from the horizontal is, kung ito siya, that will be, since that is 90, that will be 45 degrees. So, that is the unconsolidated undrained test or the UU test. So, we are on the last test, which is the unconfined compression test or the UC test. Ito ngayon yung anak ni unconsolidated undrained test. So, as you can see from its name, it is unconfined. So, meaning, wala na tayong consolidation na mangyayari. Wala nang first stage. We will jump to the second stage where we will add a deviator stress at the top or the delta sigma. And since anak siya ni unconsolidated undrained test, so ibig sabihin, our outlet pipe is still closed. So, this has a typo error. So, we will have a change in pore water pressure during the test. So, ngayon, after applying delta sigma, at a certain delta sigma or deviator stress na i-add natin, magpe-fail yung soil natin. So, since unconfined siya, so ibig sabihin, walang consolidation na nangyari using the hydraulic pressure. So, kung ipa-plot natin to on our Morse circle, as you can see, the first point in our Morse circle, which is the minimum principal stress, is plotted on the 0, 0 coordinate. Then, as you can see as well, si delta sigma or the deviator stress will correspond to the maximum principal stress of our Morse circle. Pero dito, at times, sa mga given na problems, may binibigay siya na angle of failure plane. So, kung hindi sinabi na ang angle of failure plane is 45 degrees, since kasi hindi naman siya masyadong basang-basa, unlike dun sa unconsolidated undrained, so ang tendency, magkakaroon pa ng angle of failure plane to, which is greater than 45 degrees. So, the tendency is, sa ibang problems, magbibigay siya ng angle na greater than 45 degrees. So, ibig sabihin, may chance na lumiko itong radius papunta dun sa angle of failure plane na magko-correspond dun sa theta and the shear stresses at failure. So, yun yung mangyayari on the unconfined compression test. Then, kung ganito naman yung case na ang angle of failure plane is 45 degrees, so ibig sabihin, magkakaroon ka na dito ng cohesion. So, yung cohesion na yun will also correspond to the shear stress at failure, at yung sigma natin or yung normal stress at failure natin will correspond to delta sigma divided by 2, since siya din yung radius nung circle natin. So, ibig sabihin, at this point, sigma is equal to the shear stress kasi they are both delta sigma over 2 sa unconfined compression test. So, kung gagawin natin sa soil natin, yung unconfined compression test, ganito yung mangyayari. If we have an original height of the soil, bago i-apply yung load P, at meron tayong original diameter ng soil, which is D sub O. So, pag in-apply na natin yung load, we will have a height final and a diameter final at failure. Remember, on this test, ang ginagamit nating soil sample is cylindrical. Meaning, circular yung base niya and it has a height. So, dito sa test na to ngayon, upon applying yung load P at intay nating mag-fail yung soil, since yung outlet pipe dito is closed, so therefore, walang mangyayari or walang mag-escape na component nung soil. Therefore, it means that the volume final is equal to the volume original. So, there's no change in the volume of our soil. Nag-change lang siya ng diameter at ng height. So, therefore, we can say na merong conservation ng volume, and also, we can equate the original volume with the final volume. So, as you can see, VO or V sub O is equal to velocity final or volume final. So, volume original is equal to volume final. So, the original volume will correspond to area original times the height original is equal to the area final times the height final. So, yung height final natin dito, pwede natin yung sabihin. So, let's say, this is the original height. Tapos, iiksi yan. Dahil nga in-applyan mo ng load, tapos lalaki yung diameter nung soil sample. So, this is the height final. Ngayon, since this is the height original, there is a change in height. So, that is delta H. So, kung kukunin natin yung diagram na yun, or yung changes na yun, that is the height final is equal to height original minus delta H. Kasi si delta H, that is the height original minus the height final. Kasi nga iiksi yung soil natin. So, arranging the term, we can get height final is equal to HO minus delta H. So, substituting this one to our equation, we would get area original, height original is equal to area final, height original minus delta H. So, arranging the term, ang goal kasi natin, makuha natin yung area final. So we will arrange the term. We can now have AOHO divided by HO minus delta H. So inilabas lang natin yung HO doon. So magiging ganito yung denominator, which is HO times 1 minus delta H over HO. As you can see, we can cancel out the HO, resulting to an equation, area final is equal to area original divided by 1 minus delta H over HO. So galing dun sa equation natin, which is AF is equal to AO times 1 minus delta H over HO. Pwede ngayon tayong makakuha coming from strength of materials ng equation of strain. Sabi kasi sa strength of materials, strain is the change in length or change in height divided by the original length. So, ibig sabihin, we could get a strain equivalent to delta H over HO. So, substituting this one to our equation, we could get an equation which is AF is equal to AO over 1 minus strain. So, meron na tayo ngayong area final. So, since meron na tayong area final, ang goal natin is to get the value of the normal stress. So, doon galing, or kung galing tayo doon sa Mohr circle kanina, or sa Mohr column failure diagram kanina, so, since unconfined yan, so, magsisimula tayo sa sigma 3, and automatically, this is delta sigma. So, meron din tayong sigma dito, which is the maximum principal stress. So, the goal is to get the maximum principal stress. Pero paano mangyari yun? Siyempre, si maximum principal stress, mag-o-occur yun at failure nung test natin. So, ibig sabihin, kakailanganin natin yung equation ng pressure, which is pressure is equal to force divided by the area. So now, using that one, we will have sigma 1. So we have sigma 1 is equal to P over AF, or the force divided by the area final. Area final yung gagamitin natin dito kasi si sigma 1 is a stress at failure. So, substituting area final, we could have sigma 1 is equal to P over AO times 1 minus strain. So, yung P na tinutukoy pala dito, by the way, yan yung deviator load or deviator stress na in-apply natin dun sa soil natin hanggang mag-fail. Then, arranging this term, so, that will be P multiplied by the reciprocal of the denominator, which is 1 minus strain divided by area original. So, that means we would get an equation, sigma 1 is equal to P times 1 minus strain divided by AO. Etong equation ngayon na to, yan yung gagamitin natin para makuha yung normal stress or yung deviator stress na din. So, that is the maximum principal as well as siya na din yung deviator stress natin for our Mohr circle or the Mohr column failure diagram. So, yan ngayon yung pwede nating gamitin to determine the different shear parameters for an unconfined compression test. So, ayun, ito yung mga concept na dapat nating tandaan para sa shear strength of soil. So, on our next episodes, we will be discussing sample problems on the shear strength of soil Again, this is Engineer Rodolfo. Thank you for watching, and don't forget to subscribe to Butch TV.